And welcome to section 1.4. We may go back and get some of the others later. This will probably just be a single video. 1.4 is a pretty short section. We're going to just be looking more or less just at problems from the book on this one. Let's take a look. This first problem is actually 1B from the textbook. And you can see here we have this equation, x to the fourth minus 3x cubed minus x squared plus 3x equals 0. And we're trying to find the solutions of the equation. Now, 1.4 is called solving equations graphically. So, one of the main ways you accomplish this is that obviously you graph it. How do you graph it? Well, you just set up y equals the side. Y equals x to the fourth minus 3x cubed minus x squared plus 3x. They helpfully graph that for us. And then you figure out where the y is 0. Because that's what we're trying to find, where this side, the right side, equals 0. Well, when y equals 0, it's just at these x-intercepts. Graphically, this thing is really easy to solve because you can see exactly where y is 0. Those would be the x-intercepts. That's how we define x-intercepts algebraically. So these solutions are going to be negative 1, 1, and 3. It's not hard to check those. Let's just try out 1 real quick, because I can check this in the equation. So let's see here. 1 to the fourth minus 3 times 1 to the third minus 1 squared plus 3 times 1. Well, that would be 1 minus 3 minus 1 plus 3. And that, of course, is going to be 0. So yes, indeed, 1 is a solution of the equation. And you can throw in the other solutions as well. Negative 1 should work and 3 should work as well. Now, you can also use your calculator to do some of these problems. So let's look at something a little more ugly looking. Solve the equations both algebraically and graphically. So if you get this solution, if you get this kind of problem on your homework, don't forget you have to solve it algebraically as well. That means literally solve the equation on your paper. We're going to do number 12 here, just because I want to show off a problem that you need to be able to solve algebraically, because it's going to give an irrational number as the answer. But also, it's pretty easy to solve algebraically, but you can still get an approximation for it doing the calculator process we're going to do. And honestly, let's do 13 instead. Let's do 13 instead. It'll also review doing some power equations for you guys. That'll be good for upcoming sections. So let's look at 13. X minus 5 to the fourth minus 80 equals 0. Solving this algebraically, not hard at all. Just move the 80 over to the right. Take a fourth root of both sides. So you have x minus 5 equal the fourth root of 80, which I think I can probably break down. 8 times 10. And then 8 is just 2 to the third. 10 is 2 times 5. So that is the fourth root of 2 to the fourth times 5. Oh, plus or minus. I forgot plus or minus because it's an even root. So x equals plus or minus, or gotta move that 5 over. 5 plus or minus 2 4th root of 5. Alright, that's an irrational number because it has an irreducible root in it. So if we're going to do this in our calculator, we are going to get an approximation. So I'm going to turn it on. Alright, first thing we want to do is we want to plug in this side into a y. So I just go up into the y equals menu, plug in x minus 5 to the 4th minus 80 and I'm going to go ahead and plug in something else here just for another option. I'm going to turn that off for now though. Alright, if you want you can look at the graph. Alright, that's pretty vertical. So I think I'm actually going to change my window a little bit. I'm going to drop the bottom. So I'm going to drop it, say, to negative, let's go negative 100. Oop, not 1,000, that's way too far. And let's make the top go up a bit too. So negative 100 to 50. Alright, now we get a nice sense of the loop. Now what I'm going to do next is I'm going to go, well, first off, I could probably get a decent approximation just using the trace menu here. Because if I use the keys, you can see eventually you get the cursor. Now you can go right and left and go along the function. So you can get pretty close doing this. You know, obviously it's between 7.87 and 8.08 is the solution. But your calculator can narrow it down quite a bit. To find that, you go into the calc menu. Now there are actually two ways of accomplishing what we want to do. You can do it in the zero function or the intersect function. The zero function literally finds where y equals 0. So I often use that when I have 0 on a side like this. And it's going to ask for three things. See, left bound. So it wants me to give a left bound for where it crosses the x-axis. And you see right now I'm to the left of where it crosses. So as long as you give it some room to put a guess in the middle, because it's going to ask us for two other things, and I know what they are. It's going to ask us for a right bound, so I'm going to put that up here somewhere, and a guess somewhere in the middle. So I put a left bound, a right bound up here somewhere, and a guess somewhere in the middle. And looky looky, it found us a solution. 7.99. That should be the 5 plus 2 4th root of 5. Let's see if that's true. 5 plus 2 times 5 to the... I'm just going to do a fractional exponent. Let's see. That'd be to the 1/4 power, so 5 to the 0.25. Yeah, 7.99. Obviously, it's more exact than that. I'm just giving you a round off, so I don't have to read out the whole number every time. And you know, this is an infinite non-repeating decimal, so this is just 9 digits of it. All right, and then the other one. I mean, you just do it again. Second calc, do zero function again. Well, now if I want a left bound for the other, I need to go over to the left of where it crosses. There we go. And to the right of where it crosses. And then a guess somewhere in the middle. And it gives us the other one, which is very close to 2. So that's the 2 zeros in approximation form. Notice I couldn't get their exact values like I got here, graphically. But it's still a great method because not everything's easily solvable. It's also a great check for every solve equation problem from this point forward. So keep that in mind. It's a way you can still get a solution even if you can't figure out how to solve the equation. It's worth remembering for that alone. The other way you can do this one. So the first method we looked at, method 1. Yeah, let me actually use my pen here. Method 1, we used the 0 function. Notice it is in second trace, the calc menu. And then method 2, you may like more. It's a simpler set of inputs. Method 2, use the intersect function. That's why, before I started, I put the function y equals 0 in the second y. See here, y2 equals 0. I'm going to turn that on now. Probably not going to show up because it's right on the axis. That doesn't matter. So how this is going to work is we do second, calc, and we go down to the intersect function. Now this also asks for 3 things, but honestly they're a bit simpler than the other. First curve, so you see what curve you have up here and make sure it's one of the curves you want to intersect. That's fine. Second curve, that's the other curve. We want to know where these 2 things intersect. So I'm going right now along the line y equals 0, so I just put my guess somewhere close to where they intersect, and it gives me an approximation. And honestly, that's pretty much all the theory in the section. I mean, you solve equations algebraically, you solve them graphically, and that's really it. If you wanted to do an application problem like 33 or 34, it's not really any more difficult. I guess I'll do one of these problems down here just to show that these things don't really matter that much. Solve the equation graphically in the given interval, state each answer rounded to 2 decimals. Well, the given interval here just tells you where you can find acceptable solutions. If I find x equal 3 or x equal 4 or x equal -3 or x equal -4, I wouldn't actually count them as solutions because they're not inside this interval. 3 is bigger than 2, 4 is bigger than 2, -3 is less than -2, -4 is less than -2. It wouldn't count. So if I try and solve this one, which I can't really solve this algebraically yet, I can solve it after 1.6, but I can't solve it yet. In fact, let's do 18. Let's do problem 18 just because I can't solve that. No, I can do that one. Let's do problem 17. 17 is interesting in that it can't really be solved algebraically by any method we know really now, or we might have something we can do with it later, but we'll see what we come up with. So I have x cubed minus 6x squared plus 11x minus 6 equals 0. Alright, I will once again demo both methods. Let's go a bit faster this time. So let's plug in x to the third minus 6x squared. I'll double check that's correct. Yep, that's right. Plus 11x minus 6. I'll go ahead and put 0 in y2. Doesn't really matter whether it's turned on or not. So go up in the calc menu, do 0. Oh boy. Okay, that's really hard to see from what I've got set up right now. So first I will go to zoom Z standard, because that'll get me negative 10 to 10 on both axes. Looks there like I might have 3 solutions, because it looks like it loops up, loops back down, then loops up again. Now let's narrow it down and see. This time we're just going to use the zoom in function. The zoom in function you have in the zoom menu, you have to tell it where you want it to center when you zoom in. So I'm going to put my cursor there, press enter. Oh yeah, that's good. That's just going to be perfect for doing our process here. So let's go into the calc menu, do 0. Just looking at that, it looks like 1, 2, and 3. So a left bound, a right bound. Yeah, it's a little closer than that. And a guess somewhere close to it. X equal 1. By the way, it hasn't happened yet, but sometimes in the y value it'll give you something other than 0, like, oh, say, negative 6e to the negative 13. Well, if you remember that this is scientific notation for 0.00000000013, you'd realize this is just your calculator's approximation for 0. So if it ever comes up with something like this, just assume it's still 0. So anyway, getting back here, we have 1 as a solution. I'm going to use the other method for 2. So I go back into the calc menu, use the intersect. The first curve, yeah, that's the first curve up there, so enter. y2 equals 0 is the second curve, yep, so enter. Guess about where the intersection is, should be about there. Yep, it looks like it's at 2. Why did I write 2 here? I'm at 1. Oh well. And the third solution, I'm just going to guess and check. So it looks like it's 3. Let's make sure that's correct. 3 to the third minus 6 times 3 to the 2 plus 11 times 3 minus 6. That is 27 minus 6 times 9 is 54 plus 33 minus 6. So that is negative 27 plus 27, and that is 0. So yes, indeed, the third is 3. The third answer is 3. I'll just point out here, to do the 0 method, you have to have 0 on a side. I mean, that's the whole point. It's got to be the x-intercepts. It doesn't matter what your initial setup is for the intersect function, though. So, for example, if I'd had the exact same equation, if I'd had the exact same equation, but I had it in this form, x cubed plus 11x equals 6x squared plus 6, you can see that's the exact same equation, just with this term and this term moved to the right. That's still solvable as it sits with the intersect function. Let me turn these off. If you plug in x cubed plus 11x for the left side, and then 6x squared plus 6 for the right side. Then do intersect. Zoom. Let's do Z standard again. Well, it's a bit harder to see. So let's say window is 0 to 50. Let's change my X-Men 0 to 10. This one I think is going to be hard to narrow down on the solutions just because of how the graphs are set up. So let's say 20, 50. Huh. Can't really see their intersections, can we? Well, I'm going to cheat a bit. I know where they're supposed to be. I know they're all in 0 to 4. So, 0 to 4. Doesn't help at all. Say take this equation. 16x cubed plus 16x squared equals x plus 1. To do the 0 method, I have to have 0 on a side, so I'd have to move the x plus 1 over to here, or the 16x cubed plus 16x squared over to the right. Well, I don't have to do that to use the intersect method. I can just plug the left side into 1y, so 16x cubed plus 16x squared, and then the right side into the right side, so x plus 1. I'll zoom in a little on that, but you can kind of already see pretty easily where they cross. If I do the intersect function on this, well, if you think about it, y equals this side, y equals this side. The only place that is going to be true is if the y's are equal. And those would be at the intersection points. You know, the y of one function equal to y of the other here. Ditto here, ditto here. So if we do the calc menu and do the intersect function, yeah, that's one of the curves, yes. And that's the other curve. And then a guess, well, let's just do this one right here. Negative 0.25, so negative 1/4. I do the same thing for this one over here, same thing for that one over there. Looks like the other two solutions are negative 1 and positive 0.25. So yeah, that's the section 1.4. Hopefully I'll have 1.5 up pretty soon. Talk to you later.